Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 19, we will talk about West composition. So, the concepts that we will cover in this lecture are on West composition, its global outlook, determination of West composition, how do I determine that? Then we will study two case studies, and one is from Cuttack, the data is from 2008, and the other is from different ULBs in Karnataka. The data collected is from 2012. So, if I talk about waste composition in different countries, this particular tables, this data is from 1996. You can take a look at the different kinds of, the material that is there in West. So, putrescibles are the organic matter, then paper, metals, glass, plastics, rubber, leather, textiles, ceramics. So, if you see that the first line is for Bangalore, India, where we see around 75% of the West is organic in nature. This data is again from 1996, so during that time period. So, it's a bit old, so maybe these compositions have changed now to a certain extent, but this is what we got at that point of time. Overall, West generated is around 400 grams per capita per day, and you can see that the values are different for different countries. For example, in Korea, we see the value as 22.3 for organic matter, paper 16%, metals 4%, glass 10%, plastic, rubber, leather 9.6%, textile 3%, and ceramics dust around 33%. Now, if I go to Texas in US, this value is around 43%. So, it's more than South Korea. But the other parameters like paper, it is more in case of, that means packaging and all these things are more in US. So, every country is different. You see Paris, 16% organic matter, very, very less organic matter. So, usually we say that the more developed a country is, more industrialized a country is, it would have less amount of organic content. Why? Because people are well off, they will buy a lot of packaged material, they don't cook themselves, they will, take food from outside. So, they have to buy a lot of packaging materials and so on. So, that's why the organic matter content is very less, and you'd see more amount of packaging material and other materials in the West stream. But that doesn't mean that all developed countries would be same. Like for example, in Texas, which this particular county, there maybe it's a rural in nature, so there the organic content is more. Similarly, if you take the difference between California, not California, Paraguay, the value comes to around 60%, which is much poorer country. Mexico is also 60%. So, it's also, it's well off than India, but still it's a poor country, right? So, that in that way, that means waste composition will be different for different countries. This is an average value, but what it means is, if certain cities in certain countries also will have different kinds of waste generation. Like we have Texas and we have California, both from US, but the values are different, right? So, there would be some differences as well because of the area, the context and so on. So, municipal waste composition is a categorization of type of materials in municipal solid waste. Now, MSW quantity, composition and other characteristics vary at the national level, as we are seeing here, at the urban level, at different cities the values are different, right, because each city is different in character. It varies as per the community level. Suppose it's a residential area, or it's a posh residential area or a very poor residential area, it will have different values. And it also varies among households. That means in the same residential area, there are rich people, poor people. So, individual household wise, the composition will also vary, right? So, that means that we have to be very careful about when we quantify the waste, and we have to determine that who is generating what, which generator is generating what category of waste, right? What type of waste. Because if we don't do that, then when we project it for the future, we may be making very, very wrong estimates, right? So this variation is primarily because of the degree of industrialization. Maybe when I talk about countries or maybe even cities, this play a role. The socio-economic development of that particular area, the natural resources which are available. Some area is a rural area, so obviously a lot of natural resources or the way what people consume is different from a very, very urban area. Affluence of the society, how rich people are, and the climate of that area. So all this influences the waste composition of an area. Now, along with waste which we are getting like organic waste and all, particularly in case of organic waste, we have to be also careful about global food loss and waste. So that is FLW. This accounts for a significant proportion of food and green waste. So organic waste is generated in urban areas, of course, but lot of this waste is also because of loss and waste of the food supply chain. So some of this loss is at the consumption level, but most of this loss is at the production and distribution level. So production and distribution level means during production, after production the food is stored, and because of inability to sell the product or inability of storing the product, the product may get wasted. So that means a lot of food waste gets wasted. Food gets wasted, and that comes into the waste stream. Even though it may not be part of the municipal waste stream, but it may be part of the municipal waste stream as well, if we have a lot of cold storages in our municipality. Similarly, if during transportation also, because of inefficient transportation, distribution, while food is traveling along the way, it may get decomposed. So all these issues can happen. So this food loss and waste affects food security, food safety, economy and environment, and it is approximately 30% of all food. So waste that is generated from food and green waste that is generated in urban areas may have a significant proportion of waste which is because of inefficiency in the waste production, collection, distribution, food collection, processing and distribution process, right? So there may be some amount of initiatives that could be taken to actually improve that. That will reduce the quantity of waste that will be generated. Then, looking further, if I look into the waste composition in South Asia, you will see that South Asia is again India, Pakistan, Bangladesh and these countries, right? So here we see that around 57% is food and green waste, around 15% is other waste, and metal and glass is something around 3 or 2%, something like that. And then 10% is paper and cardboard, 8% is plastic waste. So this is South Asia. Now, if I look into the overall world, very poor income countries, lower middle income countries where we are, you see this more or less matches with this particular figure. But if I go into more richer countries, you will see gradually the organic waste content is reducing. So high income countries has got a very little organic content, right? Whereas they have got a lot of paper, they have got a lot of plastic in their waste streams. So this is the difference in the waste stream in different countries. So high income countries generate relatively less food and green waste and more recyclable dry waste. Now, this recyclable dry waste means even though they are generating a lot of waste, but they are also able to recycling those. So at the end of the day, their overall waste management process is more efficient. So plastic, paper, cardboard, metal, glass, whatever waste they are generating, they are able to recycle it much more, and almost in many cases they are able to recycle it to the extent of 90 to 100%. Whereas in low income countries, recyclable materials account for only 16% of the waste stream, and within that also we are only able to maybe the material generated is maybe even a little bit higher, but we can recycle 16% or even lower. Now, how do I determine waste composition? In the last lecture, we have discussed how do I determine the quantity of waste, right? So, same way, that means once I collect samples from different generators from different parts of the city, Then the job is to determine what is the composition of waste. So we can first standard waste sampling procedure could be done to collect the waste, and samples are from different generators or different disposal sites are sorted into different categories as per requirement, and then they are weighted. So that means we can take the waste, we can separate that into different components as per our requirement. Like if I want to separate into wet waste and dry waste, that's all. If I want to further separate into plastic, paper and so on, so we have to do those separation and then we have to take their weight. So that is what we do. Now sample sizes, how many samples, when to collect, that we have discussed earlier. Now once the waste is collected for an urban area, now what we use something called a quartering and coining sampling procedure to actually determine what is the waste composition. Now, why is this method important? Because this method ensures that waste that are collected from different areas of the city and for different generators, these are thoroughly mixed, and then based on that mixed waste, we can determine what is the percentage composition of different constituents of the waste for that urban area or for that particular category of generators that we are actually addressing. But if I want to just address, look into the waste composition for commercial areas, then we will only use commercial areas and then mix the waste from all the different individual generators from commercial areas, and then we will follow this quartering and coining sampling procedure. What is this procedure? MSW is collected from random generators in the target area. That is our first step, that random generators are selected and we collect waste from them. All waste samples are mixed to form a pile. So we will first spread it out and make a pile. Then this pile is flattened out and divided into 4 quarters. So this is the flattened out pile and we divide into 4 quarters. Then 2 diagonally opposite quarters are taken out, like this side and this side is taken out. Then whatever waste is remain, they are mixed together, and then we create another pile. We keep on doing this and then we remove that again, the diagonally opposite parts could be taken out. We keep on doing this till we are left with around 10 kilograms of waste, which is the appropriate size which is used for subsequent segregation into different components and then finally weighing them or finally testing them. So this is the quartering and coining sampling procedure which is adopted for determining the composition of waste. Now coming to 2 case studies, both of these case studies has been conducted by students from our lab, and we have students working in during different like for this in different parts of the country. For example, this study was done in Cuttack in the year 2008, so it's a little bit older study. Some of the data may not match, but what we want to convey is that the waste generated in different cities are different, the composition of waste. The waste generated by different categories of people are different. So, for estimating future quantity of waste or for proposing certain measures, we cannot go with very, standards which are for the overall, the country. That means we can adopt country level standards, but we may end up with very, very wrong estimates. So, that is what I want to convey. So, in India, compostable matter ranges from 40 to 60%. So that's a very big range. So in some cities it may be 40%, some cities it may be 60%. So as per that, if I assume, if I don't do any kind of survey, any kind of estimate for that local area, and I take this figure as 50% as average. So I will design my composting plants, all these processing facilities as per that. But that will end up with lot of wrong estimates. For example, if the actual value is 40%. So that means we are overestimating by 10%. So if I say that every, for that particular city, every day, we have to handle around 50 tons of waste, that means roughly around 40, tons of waste is the actual value for organic waste, whereas 10 tons is overestimated or 5 tons is overestimated. So that builds up for, over time, and that's a lot of waste. So we need to be very, very careful about what values we adopt, and it has to be as per that particular urban area. Similarly, recyclable fraction is 10 to 25%, but that varies as per different urban areas. It depends on the segregation mechanism adopted and so on. So what we thought of is waste composition varies among income groups that we discussed earlier. Now why this is important? Now, if you remember from our earlier lectures, we said that obviously income is a big indicator of how much amount of waste is generated. Now, with time, income changes. That means people will not remain in the same income bracket because our country, at least we are growing, so our GDP is growing, so obviously income levels are increasing. So, with more income, people will consume more, and when they consume more, they will generate more waste. So, if I am making a 20-year plan or a 25-year long-term plan, so in that case, the waste that is generated in the first year and the waste that is generated in the 25th year, this would be significantly different. Why? Because the income pattern will change during this time period. Even if I assume that the people will remain there, the way the consumption patterns will remain same, that is, a person who belongs to the high income bracket in today will consume similar items in future also. That means if a rich person of today and a rich person of a future time period, they will have similar consumption. But it may change because, a lot of new technologies are coming, lifestyle patterns are changing, this will also change. But if I assume that the consumption habits will remain same, so a rich person will consume similar things if he is rich in future also. But the problem is the number of people who will become rich in future, that is not known. That we have to project, right? So a person who is LIG, he may be generating 0.3 kg of waste per day today. But 20 years down the line, this LIG person will become a HIG person because his income will increase. Then his generation would be maybe 1 kilograms per kg per day, right? So that transformation has to be asserted. So today, whoever is rich, he is consuming 1 kilograms, but in future, some LIG people of that particular city will become HIG and they will also consume 1 kilograms. So this transformation in the income is very, very important, and that's why when we did our research, we looked into how waste composition varies among the different income groups. So this data was collected in 2008. We did primary survey. We went to each household, we measured the waste that they are generated, and then we have determined what is the percentage composition of waste in these particular areas. So this is sampling strategy was household level waste collection and then weighing them. So because our sample size was less, so some of the results are a little bit, not as per the expected trend, but still it will give you an idea about how this changes. For example, we found for income level of 0 to 5,000 rupees, the average weight generated is 0.46 kg per day per household, not per capita, right? So every household may be 4 or 5 people or even 6 people there in per household. Then people with 12,500 to 25,000, their waste, the amount of waste they generated was 1.39 kilograms per day per household. And then above 25,000, it came to around 1.35, which is lower than this. This shouldn't be happening because more richer the person, they should be earning more. But it all depends on the sampling strategy, the sampling procedure, how many samples I collected and so on. If we would have collected more samples, then probably this value would be higher. But right now we can say that, well, this income brackets are showing similar consumption patterns, right? Or waste generation patterns, you can also say. So that means 1.35 to 1.4, this is the amount of waste that is generated by these richer households. Now coming to the composition of waste, you see that in the lower income brackets, food waste is around 42%, and as we go higher up, it increases a bit and then again comes down. Now why this is so? We have discussed earlier that the more richer a person becomes, he will consume more, right? Like he will consume more packaged material, he will cook less, he will eat outside, right? So that means the organic waste generated will be less. So somewhat we are seeing a value. But in Indian cities, our people are still not at that level like foreign countries where they are going to consume a lot of packaged material and all. Now, not in 1996, not in 2008 at least. Right now, still you will find a lot of families gradually moving into that bracket where they consume a lot of this packaged materials and all. But still, if you see the data, that this value is less organic matter compared to the other two groups. Okay, but this 0 to 5,000 group is also showing similar values. Actually, they are showing a little bit lower value. They should be higher as per the same logic. Why? Because these are very poor people, and very poor people don't waste, food material, food. So usually the amount of, vegetable peels generated by a poor household, and if you take a richer household, you will find that the rich person will throw out more amount of part of the vegetable which he is not going to consume, whereas a poor household will actually consume more. So probably that's why the food waste is even less in poor housing. So this kind of insights needs to come out when you do analysis of waste generated in urban areas, and that's why we need to do very, very detailed analysis to determine what kind of waste would be generated. So same goes for, paper waste. You can see that as the income level increases, the quantity of paper waste also increases. Same goes for plastic, more or less we found to remain similar. And glass also similar, scrap metal similar, because there was so less quantity, there was some amount of measurement error as well, you can say. But if we would have done a proper sampling where we have collected from multiple areas of the city, 100 kg samples, then probably we would have got much, much better results. This was done by one of our students, so it was not that in detail, right? Next, we come to a case study where we discussed waste composition at different ULBs in Karnataka, and this was done in the year 2012. Again, it was done by one of my students, Mr. Reddy. So he was engaged already in waste management in this particular state. So he was able to collect much more samples, and he has got a lot of help also from the ULBs as well. So here 4 ULBs were studied: Kamalpur, Kampli, Hospet and Bellary. See, each of these cities are different. So one is with a population of 25,000, whereas Bellary is the biggest one with a population of 4 lakhs. The number of wards also are different. Area is also different. Area is much smaller, and the ULB status or the governance system is also different. So we have a town panchayat in Kamlapur. We have a town municipal council in Kamli. Hospet, there is a city municipal council, and in Bellary there is a corporation. So we have already discussed about the municipal organization structure, the governance and all this, the finance and all this part. So all this plays a role in the waste generation and the collection process in the urban area. So again, the health officer is responsible in Bellary, whereas environmental engineers or a junior health inspector is responsible for waste management in this particular city. The total quantum of waste generated in the city is around 180 tons per day in case of Bellary, whereas it's only 8 tons per day in case of Kamalapur. Now, we are more interested in the composition of waste, right? So, again, we did a similar study that we did earlier, where we divided the population into different income brackets and studied what kind of waste, what kind of composition they generate. And this income bracket division was done so that when we do projections for the future, we do it more efficiently. I will come to that. So this is how we had done the household service. We asked people to bring the garbage outside, and then it was measured, and the total quantity and all these things was recorded, and this we repeated in multiple households. So in each of these cities, in Bellary, Hospet, Kamli and Kamlapur, we took 75 samples each. We could have gone for a little bit higher samples, but time or the manpower didn't permit it. So primary surveys were conducted in selected zones or wards in that particular ULB, and per capita waste generation at household level was calculated by taking the total weight and also the weight of each kind of component that was there in that particular waste. Now, finally, we also did project the population. To project the population from year 2001 data we had got, 2011 data we had got, but we projected the total population for the year 2021. And this was done using the incremental increase method, which was found to be appropriate for this particular ULBs. So first we projected the total population. So total population was projected. But we also wanted to understand that what would be the pattern in change of the populations belonging to different income brackets. For example, we again use range 0 to 5,000, 5 to 10,000, 10 to 20,000, above 20,000. And initially in the year 2001 and 2011, we had the data along with us. We had 27% people in 0 to 5,000 income bracket in the year 2001. Then it got reduced in 2011. That means people are moving up the income ladder. And we have to now project how many of them will move into the next income, in the year 2001, into the next income bracket. So what we did was, we knew the GDP growth rate of this particular area or this income growth rate, and from that we predicted that each of these population groups with mean income of in this particular bracket, the mean income is 2,500. Now we projected that using that rate of income growth or GDP growth for that urban area, and found out that how much of this people belonging to this group will move on to the next income bracket, which is this group. So because this value, this mean value, when we increase by 3% every year, it reached beyond this 5,000 value. And for whichever value, when starting like from 2000, suppose there are, from the income, actual income is 2000, after 3% projection every year, it became 5,000. So all people above 2000 earning now is shifted to the next income bracket in 2021. So in this way, we determine what amount of people from each income bracket will move on to the next income bracket, and you see that this is what has been projected over here. Now, why this is done? This is done so that we can say that in future the number of people in this income bracket is 15%, in 5 to 10,000 this is 30%, and so on. And the waste generated that we would estimate for each of these income groups. So we can multiply the waste generated, and we will assume that the similar lifestyle, similar kind of waste would be generated would be in future as well. So, but the quantity of people in each of these groups has changed. So automatically the total waste would also change. So that is how we did the estimation for future amount of waste that will be generated. Some more data on the survey part. What we found out was 31% responded used closed containers, 39% used open containers, 12% stored waste in plastic bags, and the rest 4% piled the waste within their premises but outside their building. So that is how waste was stored. Now, disposal behavior or collection system in that particular area, 39% were found to use door-to-door collection. This was much earlier. Door-to-door collection was not made mandatory. 19% threw their garbage in the community bins. Sometimes, even though door-to-door collection is there, people throw garbage in community bins because certain kind of garbage is generated. They don't want to keep it inside. They will take it out and throw it. 26 and 16% of respondents dump waste on roadside and open places, which they admitted themselves, right? So that means that even though door-to-door collection is there, someday the collection system may not be working, or there may be a strike by the collectors, or maybe the person missed the collection window. So he has got garbage, he throws it away near his house or in the community bin. So we found all this behavior also there in the municipal area. So, and also because we are dealing with different levels of ULBs, like Kamlapur and all, they didn't have too much amount of door-to-door collection. So most of the people either use community bins or threw the garbage outside. So that's why we see almost, equal distribution of people adopting all these measures. Now, coming to the per capita waste generation at the household level, what we determined was in Bellary, Hospet, Kamli and Kamlapur, you can see the values. You can see two trends in this. One is, as per the different income brackets, which you can see over here, the more grey ones is the richer ones. We can see a trend that the more higher the income bracket, more is the waste generated. That's a normal trend. But sometimes there are odd values. This is again because of sampling. We have taken 75 people. If we have done more samples, probably this value would be similar or even maybe higher. But because of the number of samples in this particular group, somehow on that particular day, that time when we surveyed, this showed lesser value. But usually you can see a generic trend. The other trend that you can see is, that is, in this first trend is, the more higher the income bracket, they will generate more amount of waste. The second trend is, size of the city is, the smaller size city generates lesser waste compared to a larger size city. So overall, Bellary is, the amount of waste that is generated is higher than that of Hospet, and Hospet is higher than Kamli, and Kamli is higher than Kamlapur. So as per the ULB, as per the income brackets of people in the ULB, we have to determine what sort of waste is being generated. Finally, coming to the composition of waste, not only the quantity of waste, we can see that this is table actually will give you, we have tested the composition for organic content, garden waste, because these two are taken separately, paper, plastic, cloth, wood and other kinds of waste, mixed waste you can say. So you can see, and we not only determined it for the year 2011, but we also projected it for 2021 based on the calculation that we have done earlier. That is, we first projected the population, we then determined how many people will move on to the next income bracket, and for each income bracket we know per capita waste generation, and that accordingly we multiplied and we determined the overall waste that would be generated in 2021. And then percentage composition, we assume that similar income groups will generate similar kind of waste. Accordingly, we have determined that. So over here you can see, if I take two cities, Bellary and Kamlapur, Kamlapur is the smallest one, Bellary is the largest one. Organic waste content in Kamlapur is 40%, whereas in Bellary it is 50%. The other waste, like this garden waste is the blue one, which is in Kamlapur it is very less, whereas in Bellary we are seeing some values. Paper, we are seeing around some percentage, roughly around 5-6%. Plastic, we can see some values and all, and more or less we can see that mixed waste is more in case of Kamlapur. But interesting thing is, you can see that the organic waste that is generated in a smaller city is actually less, as we have discussed earlier. And the same thing you can also see discuss for different income brackets, not only as per the city, the composition varies as per the different income brackets. So if I take the city of Bellary, you see that the lowest income group is generating around 58% of organic content, whereas the higher income group is generating 43 or lower amount of organic content. So, and similarly the plastic and paper and all is little bit more in case of this higher income group compared to the lower income group. So that is how, and again, the other interesting thing is, poor people don't have too much of garden waste because they don't have any garden. They don't have area probably for a garden, whereas for rich people, they may have a garden along with their building, so they are generating around 14% waste, which is garden waste. So every city is different, income groups are different, so we have to be very careful when we are determining that for overall for the city level or for different zones of the city level, what kind of waste is generated, what is their composition. Accordingly, we have to design the collection system, accordingly we have to design the decentralized treatment system and so on. So, overall waste generation, now coming to the final step, overall waste generation is not only the waste that is generated in residential areas or residential generators, it is also from commercial generators, street sweeping, drain cleaning, construction and demolition, and based on all this, we have estimated the total quantity of waste generated in the year 2011 and 2021 for these cities of Bellary, Hospet, Kamli and Kamlapur. So, if I take now the average per capita waste generation, including all this kind of waste, not only the residential waste, but the entire municipal solid waste that is being handled, then it comes like Kamlapur is generating around 0.34 kilograms per capita, Bellary is generating around 0.443 per capita, and Hospet Kamli is somewhere in the middle. Now, as you know that C&D waste is taken to landfill sites in India in most cases, so that's why we have included that in this calculation. And quantity of waste generated at the city level is higher than standard reference norms. So, as per standards, we are, we can adopt certain things, but as you can see in this study that the waste that we estimated is much higher than the standards. That means for effective and efficient municipal solid waste planning and management, we need to do detailed estimates of waste generation, and for that we need to do a detailed study of that particular area, and then only we can determine what are the rates, and based on that we can design the facilities or the infrastructure or the services that we require for efficient waste management in an urban area. So these are some of the references you can see. To conclude, MSW quantity, composition and other characteristics vary at the national level, urban level, community level and among different houses. So this has to be considered when you plan for urban areas, solid waste management in urban areas. Thank you.